Hello everyone, welcome to another video. This video has been in the pipeline for quite long and I've gotten like so many requests from you guys. So we're going to talk about the changes that has been done to the 2023 syllabus, and I want to just put all the uncertainties to bed because a lot of you were asking me Kesar, whether the current playlist is according to the new syllabus or not. There are few changes, there are few additions, and therefore there are a lot of subtractions. But yes, I will still stick to the fact that the current playlist will cover at least 98% of the syllabus. Okay, so let's get on to it. So the first thing that is added to the syllabus is what we call the heating curve of water. This curve actually shows how the temperature of the water changes when you convert it from solid to gas. As in you converted it from solid to liquid and then to gas by heating it. So let's get on to it. Let's say I have ice at minus 30 degrees Celsius and I started adding heat to it. Okay, so the temperature is going to rise. Minus 30 will go to minus 10, but at 0 degrees Celsius, the melting point of water will be reached. So at this point, temperature stops changing, and all the heat that you are adding is basically being used to overcome the forces of attraction between the molecules. So the temperature does not change here. Okay, so temperature remains the same, but this flat line shows that heat is being added. Okay, so all the heat is being used to overcome the forces of attraction. So this remains horizontal until all the molecules of ice get converted into water. Okay, so at this point, which I'm marking here, at this point all the ice is converted into water, and once it is done, so once you add more heat, so temperature is going to rise again. So temperature is going to keep on rising until 100 degrees Celsius, which is the boiling point of water. So again, the heat that you're adding here, is being used to overcome the intermolecular forces between the molecules. So that this heat is not increasing the kinetic energy and by default the temperature, because this heat is being used to overcome the forces of attraction. So at this point, it's all liquid here. It's liquid water, and at this point, all the water has gotten converted into steam. So again, the temperature start to rise once the phase change is done. So you need to know that when the phase is changing, what do I mean by phase? By phase, I mean the state of matter. So when the state of matter is changing, the temperature does not change. Okay, because you need to understand one thing: the temperature is directly linked to kinetic energy. If you're increasing the temperature, you're increasing the kinetic energy of the molecules, and therefore you're increasing the temperature. So if the temperature is not changing, it means the kinetic energy of the molecule is at maximum. It cannot increase anymore. So all the heat that you're adding after when the phase change starts gets used up in overcoming the intermolecular forces. Okay, so it doesn't have any impact on the kinetic energy anymore. That's why the temperature does not change. So they often ask you, what does this horizontal line mean? This means that state is changing, but the phase is not changing. So you need to know that the first horizontal change in the heating curve is melting, and the second one is, to be more precise, it's called boiling. Okay, and during melting, both solid and liquid is going to be there, and during boiling, both liquid and gas is going to be there. Now let's talk about the heating curve. This is the heating curve. Sorry, we're going to talk about the cooling curve of water, which is just the flipped version of this. So the idea here is the same as heating curve. It's just that you're reversing it. Now you're cooling water. So basically, you will be going from solid to liquid. So you're going from gas to liquid to solid, from steam to water to ice. So let's say the steam is at 110 degrees Celsius and you started extracting heat. And at 100 degrees Celsius, you need to know one thing. 100 degrees Celsius, for example, we all know that it's boiling point of water. We know that it's boiling point, but you also need to know that this is also the condensation point of water. Like when 100 degrees Celsius is reached, if you provide heat, then water is going to boil. But at 100 degrees Celsius, if you extract heat, it is going to condense. Similarly, at 0 degrees Celsius is the melting point of water. We know that it is melting point of water, but it's also the freezing point of water. So which means that at 0 degrees Celsius, if you provide heat, the ice is going to melt. But if at 0 degrees Celsius you extract heat, which means that if you cool it, then water is going to freeze. So that's what's happening here. The first horizontal point is what? Here, all the steam is getting condensed. At this point, it's all steam here, and at this point, all the steam has gotten converted into liquid water. Now the temperature drops down again, and it will keep on dropping down until 0 degrees Celsius, which is another temperature at which phase change is happening. At 0 degrees Celsius, all of it is liquid, and at this point all of it is going to be solid. जब ये सारा solid में convert हो जाएगा, then it which means that the water is converted into ice again, the phase change is complete, again the temperature is going to drop again. So the idea is again the same. The horizontal lines represent the phase change, and you need to know when the phase change is going on, the temperature is not going to change. Okay, so bond enthalpies are also, they used to be in the IGCSE syllabus, but they've also been added to O-level syllabus now. It is basically now included in the energy from chemicals chapter. So what are bond enthalpies? Obviously, the energy changes involved in bond making and bond breaking. We know that during bond making, energy is released, and during bond breaking, energy is absorbed. So they basically ask you, the question is pretty much like this. So I thought that I would get to the question immediately. So the question is asking you, calculate the overall energy change for the reaction between iodine and chlorine using the bond energies shown below. There's the reaction, and they have told you all the bonds and their energies between them, and they are asking you to calculate the overall enthalpy change. Okay, so overall enthalpy change is basically equal to enthalpy change on the reactant side here and minus enthalpy change on the product side. What is enthalpy change on the reactant side? Basically, it is the enthalpy change or the energy change when bonds are being broken, because on the reactant side bonds are being broken, okay, and on the product side bonds are being formed. Okay, so you can either calculate them individually. Let's say if I call this 1 and if I call this 2, so let's calculate 1 first. Okay, so enthalpy change on the reactant side, so there is an I bond which is being broken, so, and there is also a Cl bond that is being broken, right? So let's plug in their energy changes. I bond energy is 151 and Cl bond energy is 242. Add them together and you will get 340, 393 kilojoules. Kilojoules per mole, so kilojoules per mole. And if I calculate 2 now, which is the enthalpy change on the product side, it's ICl. There is an ICl bond. But since there are 2 molecules of ICl, there is going to be 2 ICl, right? So just plug in the energy. ICl bond energy is 208. So this would be 416. So how do you calculate the delta H, the enthalpy change? 1 minus 2. Enthalpy change on the reactant side minus enthalpy change on the product side. So 393 minus 416 would give you 23 kilojoules per mole. So this would be your delta H. It's as simple as that. And this is going to be minus, so that shows that the overall enthalpy change is negative, which means that the reaction is exothermic. So these are the type of questions that they're going to ask you around this. I'm also going to do another question जो कि थोड़ा सा different है. Let's do that first. Okay, so this is also the same type of question, just it's a bit more fancy. So let's do that. Again, you are required to calculate the amount of energy. No, in fact, amount of energy is given out. Is given, that is 780. So you are required to calculate, use this much to determine the bond energy in one SF bond. SF bond की energy निकालनी है आपने. I need to calculate the bond energy of SF. So we just need to plug in the formula and see how it goes. So delta H is equal to energy change on the reactant side. What's been happening on the reactant side? There is S. So S is just alone. There's no bond breaking going on here. But we have F2 with an FF bond. Since there are two molecules, there is going to be two FF, right? So let's do this. Minus. I'm not doing it separately right now. I'm just plugging in the values directly. You can do it separately like I did in the last question. I'm doing it differently here so that you can pick your way of doing it. Either you can, calculate the energies on the reactant side individually or on the product side individually and then subtract them, or you can do it together. And if I look at the product side, so there is an SF bond. There are four SF bonds: 1, 2, 3, and 4. So there are four SF bonds. Okay, and we need to calculate the bond energy of SF. So let's plug in the values. So delta H is given in this question, that is 780, and you are given the bond energy of FF bond, which is 160, right? And then you don't know, you need to calculate the bond energy of SF. So it's just a simple mathematical question. You just have to simplify it and isolate the SF bond energy. Minus 4 SF, right? So 780 minus 320, 780 minus 320 divided by 4, and the value that comes out will give us the bond energy of SF1. So 780 minus 320 would be, not wrong, 460, right? 700 minus 300 is 400, and 80 minus 20 would be 60. So yes, it would be 460 divided by 4. So 4 ones are 4, and then you have 4 tens are 40, and 414. I think this would be one. Okay, definitely need a calculator. Anyway, the bond energy will come out as 115 kilojoules per mole. Okay, so this would be your answer. Okay, then we have flame test now in the syllabus as well. So basically, we test. These are the tests for different metal ions, and because different metal ions give different colors when exposed to flame. So basically, if we have a metal ion solution, right? If you have a metal ion solution, we basically take a wire. It's called a nichrome wire. It's basically inert. It does not react. So it's called a nichrome wire. You dip that wire in the metal ion solution, and then you expose it to a flame. Yeah, this pathetic thing that I made is actually flame. So basically, whatever you're testing, whichever metal ion are you testing, so you need to remember the steps. That you take a nichrome wire, you will dip it in the metal ion solution, and then you will expose it to a flame. Okay, so this is the part where that's the test part, right? This is not the observation part. Observation part is the color that appears. So it can come as a 3-mark or a 2-mark question where you will have to write the test as well as the observation. For example, if it's a lithium ion, the color that would appear when the nichrome wire is exposed to the flame will be red. For sodium ion, the color would be yellow. The potassium ion, the color would be lilac. For calcium ion, the color would be orange red. For copper ions, the color would be blue green. And for there is also barium ion. Barium ion's color would be pale green. Okay, so you need to remember these tests, the colors, and how do we do that. I hope that your school or your teacher, your class teacher would have taken you to a lab and you guys have done all these flame tests. You basically, I'll just put it out again. Take a nichrome wire, dip it into the metal ion solution and expose it to a flame. And then whichever solution it is, then you'll have to write the color. If it's lithium, the color would be red. That would be your observation. So the question would come as, how would you describe describe the flame test for lithium ion, for example. And it's a 3-mark question, so that's how much you will have to write. Okay guys, before I forget, ये जो थोड़ी experimental chemistry है ना, उसमें you should know कि titration में एक change आया है. There is another indicator now. Another indicator called thymolphethylene. Okay, I would recommend to remember its pronunciation exactly like the spellings. so that the spelling does not get confusing for you. And you need to know what is its color in acidic conditions. So in acid medium, their color is colorless. It's basically colorless. And in alkaline medium or basic medium, its color is blue. So you need to remember this. Okay, moving on. Okay, this is the part that is not exactly mentioned in the in the objectives, but I would like you guys to have a more clear comparison between graphite and diamond, like physical differences as well as mostly physical differences, and the differences in bonding in the sense and the structural differences, all of that. So let's do a comparison between them, between diamond and graphite. Diamond has a tetrahedral structure. We all know that, but we don't know, most of us do not know, okay, graphite, how would you label the structure of graphite? So you would say that it has a layered structure. Okay, also in diamond, carbon makes 4 bonds. We know that. This is the bit that we have done. Carbon makes 4 bonds. I just want to arrange all the information, that's why I added this. And in graphite, carbon makes 3 bonds. And this is the reason why graphite conducts electricity and diamond does not conduct electricity, because for each carbon atom there is a free bond, there is a free electron available. And if there are a million carbon atoms in the structure of a graphite, there is going to be a million electrons. So that's what makes graphite good conductor, right? Now, they often ask you that the diamond is used in drilling, right? We know the diamond is used in drilling, right? Why? Because diamond is hard. Why? Because it has strong covalent bonds. Why? Because it has strong covalent bonds. And what about graphite? Now, when you compare the diamond and graphite, obviously diamond is harder. Diamond has stronger covalent bonds. Okay, the reason is because between the layers, graphite is weak between the layers. Here, if I just take a different color, here, graphite is weak between the layers, not along the layers, between the layers. That's why they are weak. But they have high melting point as compared to other covalent molecules, which are simple molecular structures. It's just that in comparison to diamond is softer because diamond has stronger covalent bonds as compared to graphite. Graphite has weaker bonds between the layers. That's why its layers slide. Its layers slide. Okay. If they often ask you that graphite is used as a lubricant, it is used as a lubricant. And if they ask you why, because their layers slide over each other, pretty much like metals. Like in metals, layers slide over each other. So that's why metals are slippery. And graphite is also slippery, and it is used as a lubricant because its layers slide over each other. This is just for some clarity. I just wanted to get scattered information and I wanted to arrange it together. So just remember this, okay? Okay, guys, next I want to talk about some basic nomenclature in organic chemistry. Like you might be finding, some compounds whose naming is a bit difficult, and we haven't done naming extensively. So I feel that they haven't added naming as such in the O-level syllabus, but you need to know a few things. That's the basic idea of it. First, you need to know that if you have a structure of an organic compound, every carbon is numbered. You basically number carbons, either from left to right or right to left. Either will number carbons from left to right, 1, 2, 3, 4, 5, or from right to left, 1, 2, 3, 4, 5. And how do we choose whether we go from left to right or right to left? It's if I keep it very simple, you just need to know that the side from where the functional group is closer, we number the carbons from there. For example, if I have a double bond here, right? So I have two ways to go about it. If I go from the left, 1, 2, 3, 4, 5, and If I go from the right, it's 1, 2, 3, 4, 5. Now I said that we number based on the proximity of the functional group. जिस तरफ से functional group करीब होगा उस तरफ से number करेंगे. Like from the left, the carbon that has the functional group is numbered 1, 2, 3, 4, 5, and from the right it is 1, 2, 3, 4, 5. So if you go from the left, the functional group comes at the position 1, and if you number from the right, the functional group comes at the position 4. Right? So from where it is closer? From left to right. So we'll pick this. Okay, so you need to know that each carbon is numbered. Okay, and we name according to that. For example, if we have an alcohol, if we have OH group here, right? So how do we number it? We'll number it such that the OH group is assigned the least number, like 1, 2, 3, and 4. So the carbon that is attached to the functional group has to have the lowest number. Okay? So that's how you have to number it. Now, how do we name it? There are two compounds that they actually have named, in the objectives. One is the isomers of butane, which is, I'm not showing hydrogens, okay? I'm just showing carbons here, just for convenience, okay? So if I number it, like this is a simple butane, right? But this is not a simple butane. If you number it, the number have to go from left to right or right to left. Now, there is no functional group here. If there is no functional group, then you will have to, तो फिर आपको करने पड़ते हैं नंबर उस तरफ से जहां से ब्रांच करीब होती है. Like this is the branch. What is the branch? Which is not part of the main structure. जो straight chain का part नहीं होता वो branch होती है. ठीक है, like this C is the branch. And if I number it from here, 1, 2, and 3, it doesn't matter from where I number, it still will remain at 2. So what is this 3? What is this C? We should need to know. This is CH3, right? If we just show the hydrogens here, this is CH3. So this is methyl. So how do we name it? We call it 2-methyl propane. So you need to know this name. Okay. Similarly, if we have like a double bond at the number 1 position, so we call it but1e. Okay, and if we have double bond at the second position, then we call it but2e. Just need to know these. I just wanted to, maybe आपको सब समझ नहीं आएगा. I just wanted you to get a basic idea that every carbon is numbered. Okay, similarly, if for example, again, but has an OH group at number 1 position, so it's called butan 1-ol. And for example, if it is at the second position, so it will be called butan 2-ol. I just wanted to just give you a basic idea. इसमें से अगर आपको 40% भी समझ में आ गया, it's fine, because most of it is not exactly in the syllabus, but this information may help you in solving questions. Okay guys, next I want to talk about the properties of fractions that are separated from petroleum. It's not that we haven't discussed it. You know it already, maybe I just wanted to summarize it a bit. Like for example, there is decreasing chain length, there is volatility, there is boiling point, there is viscosity. A lot of you does not know what is volatility means or viscosity means. You need to understand this. Volatility is the ease with which a liquid can be vaporized. Okay, it is the ease, I'm putting it in very layman terms, it is the ease with which a liquid is vaporized. Okay, जितनी आसानी से vaporize हो जाएगा liquid, उतनी ज़्यादा volatility होगी, which means the substances that have higher boiling points, high boiling points will have less volatility. Because they have high boiling points, so obviously they're not going to boil easily. And the substances with the lower boiling point are going to have high volatility. Okay, this is what volatility means. Volatility का connection boiling point के साथ है. Boiling point का connection होता है mass के साथ. अब you need to understand a few things, that if you talk about chain length here. ठीक है, द कंपाउंड जो कि चेन लेंथ है, नंबर ऑफ कार्बन एटम जितने ज्यादा होंगे, जितनी चेन लेंथ ज्यादा होगी उतना बॉइलिंग पॉइंट ज्यादा होगा, उतनी वोलेटिलिटी कम होगी, और इसका क्या इम्पैक्ट हो सकता है, उतनी डेंसिटी भी ज्यादा होगी, बिकॉज चेन लेंथ बढ़ी है तो डेंसिटी भी ज्यादा होगी, एंड देयरफॉर मास भी ज्यादा होगा. Okay, you need to understand the connections between these properties. That's why I just wrote it down here. The connections between chain length, volatility, boiling point, and viscosity. What exactly is viscosity? Viscosity is basically thickness of a liquid. Thickness of a liquid. Again, it is connected. Again, it is connected to chain length. The greater the chain length, the heavier will be the mass, more thick will be the liquid, and higher will be the boiling point, and lower will be the volatility. So you need to understand the connections between them. That's why I just put it out there. Okay, I hope you understood. Okay, guys. So there are also some minor additions in organic chemistry as well. Like for the reaction in which steam is added, the addition of steam reaction. Like for in ethene, steam is added, right? And we know the conditions, and alcohol is formed, ethanol is formed. And the conditions that we study is like 300 degrees Celsius temperature, and phosphoric acid is acting as a catalyst. There is also a pressure condition that is added, and that is 60 atm pressure. So you need to know that 60 atm or 6000 kilopascals. Okay, ji? And there are a lot of subtractions in the organic chemistry, which would come in really handy for you guys. As far as organic chemistry is concerned, the subtractions are there are no fats anymore, there are no carbohydrates anymore. Okay, fats, carbohydrates are removed. Other than that, hydrolysis is removed. Hydrolysis of polymers is out of syllabus now. Hydrolysis of polymers. The hydrolysis of esters is still intact, okay, still in place. And other than that, ozone is not discussed that more. There are cycles. They were used to be cycles like carbon cycles and water cycles. They are removed. There was also metal stability table. Metal stability table in metals that is being removed. I did not. I think I did not discuss it in the video as well. The recent video that I uploaded about metals. Metal stability table is not anymore. There's only the reactions of metals with acids and water that are still there, but the other table is removed. Other than that, fractional distillation of air is removed. Fractional distillation of air is removed from the syllabus. And I remember fractional distillation of air is still in the video. So distillation of air is removed. Here I'm talking about the O-level syllabus changes. Okay, I'm not talking about any IGCSE changes. So please be aware of that. Okay, so these are the major subtractions that has happened. Again, you need to know that the major ones are actually the hydrolysis of polymers and the fats and the carbohydrates. Okay, because they used to come pretty frequently. But the proteins are still there. You need to understand the proteins. The proteins are still there. Okay, so don't forget that. Other than that, recycling of metals and all of that is also removed. Okay, so these are the additions and subtractions, and I hope that it would come useful for you guys. See you in the next video.